Section 11.8, the ideal gas law. Video problems 60 through 63 follows, so make sure you go and watch those. Lots of example problems here. So the ideal gas law, it basically describes the four properties of a gas. It describes the pressure, volume, number of moles, and the temperature of a gas. R is a constant, right? It's the ideal gas constant, and that's a number that doesn't change. Okay, some constants are different for different things. In this case, that gas constant is the same, and here it is. Here's the value, 0.0821 liter atmosphere per mole Kelvin. So what this means is that our volume has to be measured in liters, our pressure has to be measured in atmospheres, our moles has to be measured in moles, and our temperature has to be measured in Kelvin, because those are the units here for that gas constant. All right. Now there are different gas constants, but it's the same number. So liters, moles, and Kelvin are the same here. The difference is atmospheres and millimeters mercury. So I just always use this one, and I convert everything so that the units are correct. Right? I find it much easier to do that. All right. Now, let me just real quick go over when to use, we have two different equations now, right? We have this equation, P1 V1 over T1 is equal to P2 V2 over T2, and then we have this equation, PV equals nRT, and a lot of times kids don't know which one to use. Well, if you are changing something about the gas, okay, you're changing the pressure, you're changing the volume, you're changing the temperature. If you're changing something, you're going to use PV over T equals PV over T. If you are just describing the gas, nothing is changing, describing, but no change, then you're going to use PV equals nRT. All right? And hopefully you'll catch on as you go and you work some more example problems. Now, we can also use the ideal gas law to calculate the molar mass of a gas, okay, and the density of a gas. Did I skip that part? Where is that part? All right, so let me show you how we can use the ideal gas law to calculate the molar mass of a gas. All right, so I'm going to do that in this space right here. So here's the ideal gas law, PV equals nRT. Right? Now, we know that molar mass is equal to grams divided by moles, right? So if I solve this for moles, right? So bring moles down there, molar mass down there. So moles is equal to grams divided by molar mass, right? If I do that, then I can plug this in. PV is equal to GRT over molar mass. And there I can find the molar mass of a gas, right? Because there's molar mass, okay? Now, like I said, I can also calculate the density of a gas. So let me bring this on down here, right? So I'm going to say PV equals GRT. This equation we just derived. Right? What is density? Density is equal to mass over volume, right? So look, here's mass, here's volume. So if I get those two over each other, so let's see, I'm going to take pressure times molar mass is equal to over RT is equal to G over V, right? I just used algebra, multiplied both sides by molar mass, divided both sides by RT, and then over here I divided by volume, right? So when I do that, I end up with this, pressure times molar mass over RT is equal to grams over volume. Grams over volume is density, right? So I can say pressure times molar mass over RT is equal to density. So there I can figure out the density of a gas at any temperature.